This video was designed to introduce you to the idea of central and inscribed angles, and also to the arcs that they intercept, since they will be critical to our discussion here. All right, first things first, what is a central angle? We define a central angle to be any angle that's formed by using two intersecting radii in such a way that the vertex of the angle is at the center of the circle. And that's important to know. A central angle has its vertex at the very center of the circle. To find the measure of any central angle, we're simply going to look at the measure of the arc that it intercepts. All right, a little bit of background first of all. The center of your circle will always be marked in the diagram with a dot. So in this particular diagram here, this circle has its center at point O, where that point is clearly marked and defined, and the name for this circle would be circle O. Now, because angle AOB has its vertex at the center O, we can conclude that angle AOB is a central angle. The arc that angle AOB intersects is going to be the arc that's bounded by the two radii of the circle. So that arc that starts at A and ends at B. So the measure of our angle AOB is going to be equal to the arc that intercepts. So this should say measure of arc AB. That's a typo in the notes. So in other words, the value of x, or the measure of angle AOB, is going to be equal to the arc that it intercepts, which is 80 degrees. All right, now a couple quick facts regarding a circle that I would hope that you would know, but if you don't, now's a good time to add that to your list of ideas that you're aware of. In a circle, there are 360 degrees. So a semicircle, or halfway around the circle, would have 180 degrees. So those are ideas that I would hope that you're already familiar with, but in the event that you're not, now you know. All right, so number one asks us to find x in each of the diagrams below. So the first thing that I'm going to do is I'm going to look for the angles that intercept the arcs and the arcs that intercept the angles. So there's the arc that we're looking for. There's x. And if I look at the angle that intercepts that arc, that angle is the angle that I just highlighted with my black pen. We don't know its angle measure. If we knew the measure of that angle that I highlighted in black pen, we would know the measure of arc x. We do know that the supplement to that angle is 120. So if this blue arc represents 120 degrees, then the angle that I drew in black ink has to be 60 degrees, making the measure of arc x also equal to 60 degrees. In the second picture, I'm going to go ahead and take a look at the angle. The angle this time I'm going to highlight with my blue pen. Notice that he has his vertex there at the center of the circle. So the arc that he intercepts is going to be the arc that I highlighted in red. If we knew the red arc, we'd also know the blue angle, but we know neither of those. That said, we know that the measure of the green arc is 250. And since the green arc and the red arc together have to total 360, we can conclude that the measure of the red arc is 110 degrees. And if the measure of the red arc is 110 degrees, the measure of the central angle that intercepts that arc must also be 110 degrees. So that's the story with the central angle. The big idea for the central angle, a couple big ideas. Number one, the central angle has its vertex at the center of the circle. Number two, the measure of the central angle is equal to the measure of the arc that it intercepts. All right, the second kind of angle that you're going to need to be able to pull away from this video is an angle called an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and is formed by two chords that intersect. So that's a big difference. Rather than at the center the vertex of an inscribed angle is on the circle. To find the measure of an inscribed angle, we're going to take half the measure of the arc that it intersects. All right, so if we take a look at the picture here, it says, and this should say angle ABC is an inscribed angle. If we take a look at where the vertex is for that angle, the vertex is on the circle, and the sides of the angle are formed by chords AB and CD. Because the vertex is on the circle, the degree measure of that angle is going to be equal to 1/2 the degree measure of the arc that it intersects. So in looking at this picture, if I extend the sides of angle ABC, I can see that the arc that it intersects, or the arc that's bounded by those two red sides of the angle, is going to be 100 degrees. Because the vertex of this angle is on the circle and it's an inscribed angle, the degree measure of the angle is going to be equal to 1/2 the degree measure of arc AC. So in other words, the measure of angle ABC, which is equivalent to x, is going to be 1/2 of 100, or in other words, 50 degrees. All right, so there are really two rules that you need to pull away from today's lesson. You have to know that when the vertex of the angle is at the center of the circle, the degree measure of the angle is equal to the degree measure of the arc. And you have to know that when the vertex of the angle is on the circle, the degree measure of the angle is equal to 1/2 the degree measure of the intercepted arc. So let's see if we can use what we've learned to go ahead and solve the problems down in example 2. Number 2 says find x in each diagram below. So if I look at angle x, there's my angle, and I'm just going to extend the sides of the angle a little bit past the arc that it intercepts to make it easier to determine that arc. I notice that the vertex of the angle is on the circle, making that an inscribed angle. So I know the measure of the angle is going to be equal to 1/2 the degree measure of the intercepted arc. Well, the measure of the intercepted arc is going to be the arc, or the part of the circle, that exists between the two purple sides of the angle. So the degree measure of angle x is going to be 1/2 of the 84 degrees, or in other words, 42 degrees. All right, let's go ahead and take a look at another one. In letter B, again, I'm going to take a look at the angle. So the angle that I've got here, again, has its vertex on the circle. And the rule for when that vertex is on the circle is that the degree measure of the angle is equal to 1/2 the degree measure of the arc. So now I need to go look for the arc that angle intersects. So that arc is going to be the part of the circle that's between the two sides of that angle. In other words, the arc that I've marked there in green. And if I go plug in, this time I know the angle is 30 degrees. That's going to be equal to 1/2 of the arc that it intercepts, or 1/2 of arc BC. And therefore, the measure of arc BC is going to be equal to 60 degrees. All right, let's go take a look at letter C. This is a very interesting and intriguing example, I think. So if we take a look at this picture, we actually have two different angles in the picture. I'm going to make the first angle green, and notice that my green angle is a central angle. The vertex of that angle is at the center of the circle. There's also a red angle. The red angle is an inscribed angle with its vertex on the circle. Both the green angle and the red angle intercept the blue arc. So my rule for a central angle says the degree measure of the angle is equal to the degree measure of the arc. So in other words, the degree measure of my angle here is 70 from the picture, is going to be equal to the degree measure of the arc. So in other words, that blue arc measures 70 degrees. And now that I know the degree measure of that blue arc, Now I can go find the measure of my red angle, my inscribed angle. My inscribed angle has its vertex on the circle. There's his vertex right there. And he follows different rules than the central angle. The rule for the inscribed angle says the degree measure of the angle is equal to half the degree measure of the arc. So in this particular case, the degree measure of my angle is x. The degree measure of my arc is 70 degrees. And half of 70 degrees is 35, making the value of x equal to 35. All right, so there were a lot of good key ideas and important understandings that you need to pull away from this short little 11-minute video. So go ahead and make sure you take some time to put those key ideas in your own words so that they'll be meaningful and rememberable for you, if that word rememberable is a word. And then see if you can apply what you've learned in this video in order to solve the questions on the following page.